We're going to finish this problem with two application problems. Example 4 says the value V of a Chevy Cruze LT that is T years old can be modeled by, and then here's my equation here. According to this model, when will the car be worth 12,000, 9,000, 3,000? So this right here stands for my V. My V is here. So I'm wanting to know when will it be worth. I am solving for my T, which is an exponent. Now, you can plug in 12,000, then 9,000, then 3,000 and solve this equation 3 times for T. The easiest way though is to rewrite this equation and solve it for T, and then it's just plugging in numbers. So if I rewrite this, we've got V equals 19,200 times 0.82 T. Your rules for exponentials, if I can find them right here, is to isolate the exponential term. This is my exponential term. So before I can do anything with this, I need to move this over by dividing. So we'll divide both sides by 19,200. Those cancel. So I have V over 19,200 equals 0.82 to the T power. My second step is to take the appropriate log to both sides. If I want to get rid of an exponential with a base of 0.82, I am going to multiply both sides with a log of a base of 0.82. So that cancels, and now I just have the exponent, which is T. I'm going to get T equals log of 0.82 to the V over 19,200. So now I'm going to take this equation that is now solved for T, which is what I'm wanting to know. When will the car be worth? And now I'm going to plug in my values for V. So this is now just plug and chug. So with this, definitely using the log base. So log base of 0.82. And then we have V, which in my first one is 12,000. So 12,000 divided by 19,200. And it is thinking, I think. There we go. Maybe I didn't hit enter. Okay, so going to be worth that in about 2.3 years. So now this is easy. Now I just come back up here and change my V to 9,000. So now in about 3.8 years, it will be worth 9,000. And then change your 9,000 to 3,000. And it will be worth 3,000 in about 9.4 years. So the work here is taking this equation and solving it for that exponent, which is what this lesson is all about. Okay, same thing on example 5, but it's actually a little bit more complicated. But we're not scared because we have a great teacher who has guided us. Example 5. The resident population of the United States in 2018 was 327 million people and was growing at a rate of 0.7% per year. Assuming that the growth rate continues, the model right here represents the population P in millions of people in year T. According to this model, when will the population of the United States be 415 million and 470 million. So again, when I'm solving for a t, so I need to take this equation and solve it for my t, which is in that exponent position. Because this right here is talking about P, my population. So let's rewrite this. And solve for T. So the first step is to isolate the exponential term. This is my exponential term. So I need to divide everything by 327. So I have P over 327 equals what I have in that circle, 1.007 to the T minus 2018 power. Okay, second step is to take the appropriate log on both sides. If I want to get rid of this exponent with a base of 1.007, then I am going to take the log of 1.007 to both sides. So that cancels there, and I have log base 1.007 of P over 327 equals, and this is going to come down, so T minus 2018. So then my last step here to get T by itself is to add that over. So my T equals log of 1.007 P to the 327, add that over, plus 2018. So now that my equation is rewrote for T, now I can plug in my P's. Okay, so calculator. All right, we would have math, log base, 1.007. P, my first P is 415. 415 divided by 327 plus 2018. So it's going to have a population of this in the year 2052. So now I'll come back up here and I will change 415 to 470. And it will have a population. Sorry, I can't write and talk at the same time. It will have a population of 470 million people in the year of 2070.